Hello, welcome. Myself, Mary Andrews, Assistant Professor, Department of Computer Application, St. Teresa's College, Ernakulam. So today we will be learning about probability, the basic definitions of probability. Okay, we won't be going into the detailed definition of what probability is, but yes, the basic definitions, in the sense I want you to know about the basic terminologies that we are using in probability theory. Before going into the definition, we should know some basic terminologies. Yeah. So, as I said, we will be going to discuss about the basic definitions and terminologies that are used in probability theory. Um, okay, so probability theory is a very fascinating subject. It's not at all boring. It is always connected to our day-to-day life, and which can be studied at various mathematical levels. Probability is the foundation of what the statistical theory and its application. Now, the basic things that we are going to learn in today's session is what is probability. I'm not going to define any definitions regarding probability right now, but simply what probability means to us in our day-to-day life. Then the second one is experiment. Then we will study about random experiment, outcome, trial, events, and sample space. So that is what we are going to cover in this session. Now, what is probability? Probability is what is probability? The term probability in statistics refers to the chance of occurrence of an event among a large number of possibilities. For example, if it is a rainy season and if you want to take your umbrella, what would you do? You would step out of your house and just check whether it's raining or not. If it's raining or not, and if it's not raining, would you 1 second into your mind it would flash the idea that yeah, it might rain today, or there is a chance of there is chance that it would rain today. So these phrases are being used in our day-to-day life, and the chance or it might rain, all these things are connected with what probability. So you are unknowingly using probability theory in your day-to-day life. Now I'm moving on to some important terminologies that you should know. Now, experiment, that is the first terminology. Again, experiment, I know all of you might be doing experiments in your day-to-day life, or every day, each or every day you will be doing your experiments. Now, what is an experiment? If we give a definition for an experiment, it is an action which we do or intend to do. So usually there are two kinds of experiment. One is to the deterministic experiment. Now let's see what is deterministic experiment. So in a deterministic experiment, the result or the outcome is unique or certain. Okay, so just think that we will come to an example, and we will detailedly look into what deterministic experiment is all about. Now, here chance does not play any role, so that means probability has no role in deterministic experiment. Now let's look at an example. If you want to find the velocity of a quantity after time t, when you know the velocity, the formula for velocity, and that is v is equal to u plus at. So if you are given the quantities u, a, and t, you can easily find out what v. So that means here, okay, again, for those who don't know what is u, a, and t, u is the initial velocity, a is the acceleration, and t is the time. So if you substitute all these values in the formula, you will get a unique value for v. And even though if you repeat the experiments a number of times, this v will not change. Okay, so that is why we say that deterministic experiment has a very unique result, and chance does not play any role here. See, repeated any number of times, the outcome will be the same. Now let's move on to the non-deterministic experiment. So here chance plays an important role. Again, the result is unique, but maybe one of the several possible outcomes. And the outcomes need not be the same even if we repeat the experiments under uniform conditions. We'll check an example. We'll have a look at the example. For example, if you have a coin and you flip it once, but are you sure you will get a head or a tail? No. So there is an uncertainty. So definitely chance plays a role here, and you might get a head or a tail. So that is why this experiment is called as a non-deterministic experiment. I hope you have all understood what is deterministic and non-deterministic experiments. Okay. So next we will move on to what is a random experiment. So before going into the definition of a random experiment, we will have a look at an example. Again, we have a coin with us. It is an unbiased coin and we are going to toss the coin. Now all of you know what are the two possible outcomes. It's a head or a tail. So you have two outcomes. Now this experiment can be repeated any number of times. I haven't given any restriction for that. But what happens if you repeat any number of times? The same thing that I said earlier, the outcome of each trial cannot be determined with certainty. So there is an uncertainty in this experiment. And hence the coin tossing experiment is a random experiment. Now, keeping this example in mind, I'm going to break down the definition of random experiment. We haven't arrived at the proper definition of random experiment, but I'm going to break down the definition and connect with this example. So random experiment, the definition of random experiment says that it has more than one result. So let's have a look whether it has more than one result. Yes. So we have two possible outcomes here, head and a tail, so more than one result. Then outcomes of which vary in an unpredictable manner from trial to trial. Yes, if we repeat the experiment, we are not sure whether we could get a head at the first time or tail at the first time. So it's unpredictable, or the result is uncertain, that there is an uncertainty. Then repeatable under uniform condition. Yes, you can repeat this experiment under uniform conditions. So that is what is random experiment. Now let us have a look at the definition. So random experiment, an experiment which has got more than one result, the outcomes of which vary in an unpredictable manner from trial to trial, and which is repeatable under uniform condition, is known as a random experiment. Now the other next terminology is outcome. Outcome is very simple to understand. The result of an experiment is known as an outcome. Okay, so I don't think that you need an example for what outcome is. Okay, now the next terminology is trial. Now let's see the definition. Any particular performance of a random experiment is known as a trial. Just give emphasis on this random experiment word. So let's take a look at the example. Again, I have considered flipping a coin once again. So tossing a coin once is considered as a trial, and tossing a coin two times will constitute two trials. Similarly, if you have a die, if you roll a die once, it is called a trial. It is called one trial, or you can say it like that. If you are rolling a die 5 times, then it constitutes 5 trials. Okay, so it's as simple as that. Again, if you roll the die n number of times, then it constitutes n trials. Yes. Now let's move on to the next terminology, that is events. So let's see what an event is. An event is an outcome of a trial meeting a specified set of conditions. So for explaining this definition, I would have to detailedly examine what all events are there. There are several kind of events, and yeah, as I said, event is the subset of sample space S. Now what is a sample space, that we will come to later. The last topic is sample space. So just understand that event is a subset of sample space S. Now sample space is the set of all possible outcomes that can happen. Okay, for example, if you flip a coin, the two outcomes are H and T. So that means a sample space in that particular experiment is what S is equal to H and T. So we will come to that in detail later. Yeah. So what is an event? Through an example, I would say, when two coins are tossed, let's define let A be the event of getting at least one head. Okay, whenever I write or define an event, I would write something like this: A colon be the event of getting at least one head. So let's see what the answer is. Therefore, A is equal to, put a set, inside the set you write what at least one head. I have said at least one head. When you toss two coins, what are the possible outcomes that you get? HH, you can get HH means what? The first coin shows up a head, second coin shows up a head. Second one is first coin shows up a head, second coin shows up a tail. Third, first coin shows up a tail, second one shows up a head. And again you have a fourth one, but in this you can't include the fourth one, that is TT. Both the coins can show up a tail, but you can't include it here. Since our event is, what is our event? The event of getting at least one head. So we have defined A like this. So that's why we have these outcomes. Okay. Now, as I said earlier, we have to, go through all these events before explaining the classic definition. So let's take a look into the events, different kinds of events. The first one is the elementary event. So as the name suggests, the definition is event which contain only one event. So let's have a quick look at the example. Again, I'm taking the example of tossing a coin. Let A be the event of getting a tail. Okay, so what will be the answer? Just just write down the answer in your mind or in a piece of paper. What is it? Yes, it is A is equal to head. So that means that we have only one outcome, and yes, this example justifies this thing, that is the event which contains only one event. Next is composite events. Let's see what composite events is. An event that contains two or more outcomes. So let's have a quick look at the example. So here I haven't taken a coin. I have taken a die. You can take a coin if you want, but here I have taken a die. So rolling a die, and let B be getting an even number. So as you know, a die has 6 phases: 1, 2, 3, 4, 5 and 6. So if B is the event of getting an even number, so what are the possible even numbers that can take place here? 2, 4 and 6. Let's check the answer whether it's 2, 4 and 6. Yes, so B is equal to 2, 4 and 6. So we have to just check whether this event is a composite event. So let's see, an event that contains 2 or more outcomes. Yes, B is equal to 2, 4 and 6. So that means it has more than 2 outcomes. Okay. So next is sure or certain event. So let's have a look at the definition. An event which contains all outcomes of a sample space is called a sure or certain event. Example, again I have taken a coin, tossing a coin once. Let C be the event of getting H or T. C be the event of getting H or T. So what will C be? C is equal to H comma T. So that means, just have a look, it has all the possible outcomes. That means, what is it? An event which contains all outcomes of a sample space is called a sure or certain event. So the next one is null or impossible event. So null or impossible event, as the name says, it's something connected to 0. So let's have a look at the definition. An event which contains no outcome. Yes, so we'll look at this example. Rolling a die once, let D be getting the number 8. So just give a thought. Getting number 8. As you know, rolling a die has 6 phases, only 6 phases, so it is impossible to get a number 8. So what is D? Yes, it is a null set. So therefore, this example justifies this definition: an event which contains no outcome. Now, exhaustive events. What is exhaustive events? Now let's take a look at the definition. The total number of all elementary events, all elementary outcomes of a random experiment. So you have studied about the elementary outcomes, elementary events earlier. Let's take a look at the example. When a coin is tossed once, okay, take a coin, You toss it once, you get two possible elementary outcomes. What are they? H and T. Yeah, so that was an exhaustive event. Now, favorable events, let's have a look at the definition. The cases which contain the occurrence of an event. Okay, let's see an example. You throw a die, and I have defined A as getting a multiple of 3. So here A is defined as getting a multiple of 3. So in the case of throwing a die, what is the possible numbers that A can take? Let's see. Okay, A is equal to 3 and 6. 3 is a multiple of 3, 6 is a multiple of 3. Okay, fine. So how many favorable outcomes are there? Yeah, the total number of cases favorable to the event A is 2. So that means the cases which contain the occurrence of an event is called favorable events. Now, mutually exclusive events, or you can say it as disjoint events. Now let's have a close look at the definition. Events are said to be mutually exclusive if the occurrence of an event totally prevent the occurrence of all other events in a trial. So let's see with an example how can we break this definition. This is a huge definition, but you don't worry. So I'm going to take an example of tossing a coin. Now I have defined A be the event of getting a head, and I have defined another event B be the event of getting a tail. And I hope you know, if you toss a coin, only one event can happen. Okay, if the event A happens, B won't happen, and vice versa. If B happens, A won't happen. So that means here, if A happens, it prevents the occurrence of what? The event B, right? Similarly, vice versa. So yes, as I said, the occurrence of A prevents B from occurring, and vice versa. Here A and B are mutually exclusive according to our definition, and we can mathematically write it as A intersection B is equal to a null set. Next is non-mutually exclusive event. So let's have a close look at the definition. Events are said to be non-mutually exclusive if they occur simultaneously. Okay, so let's see what the examples say. So I hope you all know certain things about cards, right? So drawing a pack of cards contains 52. A pack means 52 cards. Okay, so keep that in your mind. Now drawing a single card from a pack of 52 cards. So that is the example that I have taken, or the experiment that I am planning to do. So I have defined an event A, that is event A is getting a jack, and event B is the event of getting a club. Now in this case, there is a possibility of getting jack of a club, right? If you draw a card, you can get a jack of a club. So that means if event A happens, it is not necessary that it can prevent B from happening, right? And vice versa. So that means here A and B are non-mutually exclusive. Now equally likely events. Now let's take a look at the definition. The outcomes of an experiment are said to be equally likely if all of them have an equal chance of occurrence, or one of them cannot be expected in preference to the others. Now here again, it's a very big definition, but don't worry, with an example we can break down. So we are tossing a coin once. Here the occurrence of head or a tail has an equal chance, right? So that's it. So, and the occurrence of head or tail is equally likely, and that's why they are called equally likely events. So that's it. That is the definition. It's the example justifies the definition too. Now, what are independent events? If events are such that the occurrence or non-occurrence of one does not affect the occurrence or non-occurrence of the others, then we say that they are independent events. So I know by reading this definition you won't understand anything, so we have an example. Take two coins, first coin and the second coin, keep it aside. Then toss the coin together. So let A be the occurrence of head. Okay, I have defined A as occurrence of head in the first coin, and I have defined let B be the occurrence of head in the second coin. You flip both the coins together. Does A prevents B? No. If you flip the coin A and if you get a head, it does not prevent the occurrence of happening of B, right? So here the occurrence or non-occurrence of A does not affect the occurrence or non-occurrence of B, and therefore A and B are independent events. So thank you for listening to this session. We will continue this session in